questions 21 through 25 of the 2002 Grade 8 AMC 8. Harold tosses a nickel 4 times. The probability that he gets at least as many heads as tails is. So he tosses a nickel 4 times. So what possibilities do we have? We can have 4 heads and 0 tails. We can have 3 heads, 1 tail, 2 heads, 2 tails, 1 head, 3 tails, and finally 0 heads and 4 tails. Correct? Now, for each of these, what possible combinations are there? Well, for the heads being all the time, you have basically this scenario. Correct? He tosses it once, it's heads, tosses it a second time, it's heads, and so on. So for that, that's the only possible way of doing that. How about if you have 3 heads and 1 tail? Well, you can have that as follows: H, 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 T, H, H, T, H, 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 T, H, H, and finally T, H, H, H. Okay? So I hope that makes sense. Now let's do these ones instead of going to the middle one, because these two are very similar. What did I write there? Oh, sometimes I can't read my own handwriting. 0H and 4T is just T, 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 right? And then this one is very similar to this one up here. 1H and 3T. So we have T, 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 H, T, T, H, T, and T, H, T, T, and then finally H, T, 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 like that. Okay? Now this one is 2H and 2T. So H, H, T, T, H, T, H, T, T, H, H, T, T, H, T, H, T, T, H, H, and finally there's one more, I believe, H, T, T, H. All right, so that represents all the combinations. So what is the total? We got 1 here, 4 there. We have 6 here, 4 here, and 1 there. So there's a total of 5, 5, and 6 is 16 total possible combinations. Okay? Now, the wording of this is a little tricky. The probability that he gets at least as many heads as tails. Please don't jump into the trap that they want you to figure out only when the number of heads are the same as the number of tails, which is this scenario. Because if you did that, you'd say, oh, okay, that's 6 over 16. That's 3 over 8. Choose B and off you go. Well, unfortunately, that's wrong. Why is it wrong, though? Well, they want at least as many heads as tails. So, for example, if you have 2 tails, they want you to have at least 2 tails. Okay, we satisfy that. So these ones are the ones that we want. But what about this scenario? You have 1 tail. They want you to have at least 1 tail. Do you have at least 1 tail? Yes, you have 3 of them. So that is also correct. Here you have 0 tails, right? So they want you to have at least 0 tails when you choose heads. And that also matches. Does that make sense? So let me go back and explain this one again. They have 1 tail, right? They want you to have at least, therefore, 1 head. As least as many heads as tails. That's I don't know if you guys find it confusing. I find it confusing, but maybe you don't. But in any case, if you add up those ones, you get 1 plus 4 plus 6, which is, of course, 11 over 16, which is the correct answer. So 21 is E. Six cubes, each an inch on an edge, are fastened together as shown. Find the total surface area in square inches. Include the top, bottom, and sides. So each of these cubes has a surface like that, and they're saying that it's 1 by 1. So that means that if you have a square that's 1 by 1, its area, of course, would be 1 times 1, which is equal to 1. So that's the first part. Now we have to count how many squares are there. So what I'm going to do is just break them up into a few categories. The first category is facing me. The next category is facing the back. And then facing right, facing left, facing up, so facing top, and then facing bottom. All right, and then let's figure out how many we get. Facing me, okay? Let's see here. How many are facing me? I've got one here, another one there, another one there, and another one there. So that's 1, 2, 3, 4, 5 facing me. All right, facing back would be exactly the same, right? The ones that are facing me will be also facing behind. I hope you are convinced of that. Now facing right, so how many if you're looking at it from that way? Well, it looks like you got one there, one that's sort of in there, and one there. So 1, 2, 3, 4. So for facing left will be the exact same. Or will it? No, it won't. This diagram is not that of that nature. So we have to kind of look at it from a way that we can't even see. But if you do, you'll find there's one there and there's one that's there. Then there's one over here and one here, right? So that's 4. And then facing top, okay, we can actually see the top. One there, one over here, and one over there. And that's 4. And facing bottom, I believe the bottom, let's say we have one that will be below there, one that will be below there. What I drew on the top, it'll be below there. One below here and one below right there. And I think that covers all the ones on the bottom. Well, so a little bit of visualization necessary. And the total looks like 10 plus 16, which is 26. And each of these 26 faces has an area of 1. So the total surface area is 26. So that is C for number 22. Oops. Sorry, not C. Yeah, C. I don't know why I confused myself. All right, so we have the corner of a tiled floor as shown. If the entire floor is tiled in this way, and each of the 4 corners looks like this one, then what fraction of the tiled floor is made up of the darker tiles? So I believe sometimes just using the diagram they give you is sufficient enough instead of redrawing it. So here is the blow up of this diagram, and I just have to figure out the ratio of the shaded area to the total. Well, they don't give us much information, but I'm assuming that all of these are equidistant, right? So from here to here is the same as from here to here, like that. So I'm just going to call them 1 by 1, 1, 1. And therefore, each of these, if they're 1 by 1 little squares, each of them would have an area of 1, correct? Because 1 times 1 is 1. So I'll break up the shaded area into squares. So how many squares do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I've got 12 squares, and each of them has an area of 1. But I also have these ones, which are essentially triangles, and because they are half of the square, each of them will have an area of a half. Okay? And how many of those? We got 1, 2, 3, 4, 5, 6, 7, 8. Plus 8 triangles, and each has an area of a half. All right? So, what is the total? Because they want the fraction, right? So the total is 1, 2, 3, 4, 5, 6 across, and 1, 2, 3, 4, 5, 6 on the side. So the total area is 6 times 6. So there you have it. This will give you 12 plus 4 over 36, and that is 16 over 36. That reduces to 8 over 18, further reduces to 4 over 9. 4 over 9 would be choice B. Mickey has a dozen oranges of the same size and a dozen pears of the same size. Mickey uses her juicer to extract 8 ounces of pear juice from 3 pears and 8 ounces of orange juice from 2 oranges. She makes a pear-orange juice blend from an equal number of pears and oranges. What percent of the blend is pear juice? So from the juicer, if she has 3 pears, she gets 8 ounces of pear juice. That's according to the question. And then if she has 2 oranges, 2O, you get 8 ounces of orange juice, of OJ. Okay, and this O is bothering me. I put a little R there. Otherwise it makes me think it's a 0. And then I don't know what I wrote. So the key in this question is that there's an equal number of pears and oranges. So this scenario we can't use, right? Because 3 is not equal to 2. But what if I made them 6 and 6? That would be equal, correct? All right, so if you have 8 ounces from 3 pears, how many ounces from 6 pears? Well, it would be twice. So that would be 16 ounces of pear juice. And then similarly, if you have 8 ounces from 2 oranges, how many ounces from 6 oranges? Will be 3 times that, so 24. And now the question is interested in the amount of pear juice in this blend. So if we were to mix all of this juice together, you would have a total of 16 plus 24 ounces, correct? But the pear juice is represented by 16 ounces. So that is our fraction. So 16 over 40, and this reduces to 8 over 20, which is 4 over 10, which is 2 over 5. Oh no, they want a percent. Oh, I'm doing fractions. Well, 4 over 10 is 40%. So 24 is B. Loki, Mo, Nick, and Ott are good friends. Ott had no money, but the others did. Mo gave Ott 1/5 of his money, Loki gave Ott 1/4 of his money, and Nick gave Ott 1/3 of his money. Each gave Ott the same amount of money. What fractional part of the group's money did Ott now have? So we have L for Loki, M for Mo, N for Nick, and O for Ott. And initially, I'll just let the letters represent the amount of money. So initially, this is how much money they have. The group's money would be L plus M plus N, and Ott has 0, so that wouldn't need to be added initially. So I'll write that on the side. L plus M plus N is the group's money. And then what happens is each of these 3 friends gives Ott a certain amount. So Mo gives 1/5 of his money. So M over 5 is how much Mo gives to Ott. All right. And then Loki gave Ott 1/4 of his money. So L over 4. And then finally Nick gave Ott 1/3 of his money, so that's N over 3. So these are the amounts that Ott receives. Now, if that is the case, then these 3 amounts are no longer L, M, and N, correct? They're a little bit less. So this is now 4M over 5, right? Because you've given 1/5, so 4/5 are left. This is now 2N over 3. And L is now 3L over 4. right? Just simple subtraction of fractions. Now, what are they asking for? What fractional part of the group's money does ought now have? Okay, so ought now has m over 5 plus l over 4 plus n over 3 all over the group's money was represented by L plus M plus N. So this is how much ought has. And they want you to obviously figure out a fraction. Right now we have L's and M's, and that's no good. All right, no problem. Should be able to do this, but there's one key part of the question that definitely needs to be highlighted. This part right here. Each gave ought the same amount of money. That's very important. That means that this is equal to this is equal to this. All right, each gave ought the same amount. So that means that m over 5 is equal to L over 4 is equal to N over 3. Okay, that is the key to solving this equation, or whatever we have, fraction. All right, so we can now get this all in terms of one variable, I hope. I'm going to use m as the variable that I keep. L over 4, well, L over 4 is equal to m over 5 right there. So instead of having L over 4, I'll just put in m over 5. N over 3 right here, well, that's equal to m over 5. So instead of writing n over 3, I will write m over 5. Okay, so that takes care of the numerator. Now, what about the denominator? I'll keep my m, but L and m I want in terms of m. Well, I go right back to the same equalities. If I want m and L in terms of one another, they're already in terms of one another. So if I cross multiply that one that I just underlined, you get 4m is equal to 5L, and therefore L is equal to 4m over 5. So I'll put that in here, 4m over 5. And then these ones will give me a value for n in terms of L, but I actually don't want that. I want n in terms of m. So I'm going to use those two. So that means m over 5 is equal to n over 3. So 3m is equal to 5n, and therefore n is equal to 3m over 5. So that means n here is 3m over 5. All right? And this is how much odd has in terms of a fraction of the group's money. So we can solve for this. The top looks like 3m over 5. The bottom, we're going to need a common denominator, so that's going to be 5 over 5. So that will be 4 plus 5 plus 3, which is 12m all over 5. And then invert and multiply. So you'll have 5 over 12m. The 5's cancel, the m's cancel, right? And that leaves just 3 over 12, which reduces to 1 over 4. So 1 over 4 is our answer, and therefore, number 25, the answer is B.